Hi and welcome to this video about extending a scripting host. So this is a continuation from the previous video when we learned how to create a simple scripting host that hosts VBScript or JScript code. So if you haven't watched the previous one, I recommend you do that. So I want to show you a couple of ways we can extend the scripting host in perhaps some non-trivial ways. So let me go back to the code here. What we've done is we just created a simple scripting engine. In this case that would be VBScript. Then we had our host, we attached the script engine to the host, and then we use that to run some script. And of course we can do that in a more generic way by passing functions, creating functions using any capability that VBScript in this case supports. We can even create classes in VBScript and all sorts of things we can do. It really depends on the scripting engine itself and its capabilities, and of course the language being used here. We can also use a file, an external file, to load that as a script and then run that thing. But let's see what else we can do as it relates to the host itself. So notice here in this little example I'm using this shell. This is just a variable name, so I can change that to whatever I want, something like this. So you can definitely do something like creating an object. This is a COM object that has a programmatic ID of shell.application, and then we're invoking various methods on that object, such as this explore method. So that's all good and well, but maybe we think that this particular kind of object is really just a singleton. It's supposed to be kind of a singleton. It doesn't really have any kind of state. It's just there to provide functionality related to the shell. Maybe instead of the client having to create this object explicitly and needs to know that this kind of programmatic ID actually exists, maybe we want to do something simpler. Allow the client that uses the script to just use a named object that refers to this instance, but doesn't have to create it explicitly. So for example, we can say, let's use shell here. So shell is going to be a named object that represents this particular object that we created previously explicitly. Now obviously if I try to run this right now, this probably wouldn't work, because the VBScript engine is going to say, you know what, I have no idea what shell is. I don't know how to invoke anything on that. I'm going to run this just to verify. And you can see we get the enter and exit script as usual. We have the message box, but then when we try to call the function explore on this shell object, we get an error. And that error is going to indicate something that object required shell. So shell here is just like a local variable that has a value of null or nothing, as it's called in VBScript. So essentially you're trying to invoke a method on non-existent object. So we want this to actually work. What do we need to do in order for this to work? So here's what we need to do. We can go ahead and after connecting the host to the script engine, we can say to the engine, let's add a named item. We can add a named item, which is a way to indicate to the script that there is another thing it needs to know about, and when the engine needs to know what that thing actually does, it calls back to the host. So we can say, here's a name called shell, and then there's a bunch of flags we can use, and in this case what we want is a script item indicating visible, which means that we want this thing to be visible in the script itself, so scripts can use this name shell. So what happens then is that every time the name shell appears, and in this case VBScript technically is not case sensitive, but it's going to send this string to a callback that is implemented by the host. It's one of the methods in the iActive script host that it needs to implement. In this case, that method is called get, something like get item info. This is the one. So this method currently does nothing. It just returns e not impl. And as we'll see when we go ahead and put a breakpoint here, let's do that. And let's run this again. I'm going to remove some of the breakpoints we had previously because they're not very useful, like enter script and get window. We've proven that these things work. And let's continue. Here's our message box appearing, and then we can see get item info is being called. And the string provided here is the string used by the client, that is by the script, in this case shell. And then we need to return something here. We need to return an object. If we return an object, then it's possible that we'll be able to continue doing something. But if we return in not impl, or something that doesn't put anything into this item, this interface pointer, then we'll just get to the same kind of error. Again, the script says I don't know what that thing called shell is. So the error is slightly different because the engine does call our method, but we didn't provide any useful information, so the script can't really continue. So what we want to do is to implement that get item info in a way that would make this thing properly work. And so to do that, what I'm going to do, I'm going to create a smart pointer here that's going to point to an iDispatch. I can use iDispatch or iUnknown, doesn't really matter in principle, because at the end of the day, we know that every object that can be used by scripts are objects that must implement the iDispatch interface. This allows the late binding kind of thing where we call a method or a property based on its name. And talking about iDispatches is a bit too much for this particular video. I might save that for a different video. And you can also use iUnknown, by the way, because that's also going to be supported, of course, because iDispatch derives from iUnknown, and iUnknown is the COM interface that must be implemented by all COM components or COM classes. But I'm going to use iDispatch to make it a bit more concrete, so that we don't create an object that doesn't support iDispatch, which of course it's not going to work out. So COM pointer here is not properly supported. We need to just add the ATL COM client header to get the support for the smart pointer to be nicer. So we have this shell kind of thing, and then when we go to get item info, which is the thing we want to implement here, what I want to do, I want to first make sure that we're talking about the object that we're actually trying to provide. So we need to make sure that the name is the one that we're looking for. So I'm going to use the WCSI CMP function, that's the straight kind of C function, to compare with the name shell. That's the thing we want to compare to. So this I thing means this is an insensitive in terms of case, which means that I don't care if the client uses shell or whatever. I want to do a case insensitive comparison, because this is what is expected by VBScript scripts. So if this is 0, it means that these are actually equal. We want to do something about that. Otherwise, we know that we can't really provide anything. So I'm going to just return invalid arg to be a bit more explicit, but even in not impl works as a way to indicate an error, as we've seen. And so if we do get to this location, I'm going to look at what we have in our shell. If this is null at this point, which means we have not created our object yet, we're going to just create it in the usual way by using co-create instance, and we know the programmatic ID is shell.application, so I'm just going to use that. Exactly as in fact the script is doing behind the scenes if it does call the create object VBScript function. And then we can go ahead and return the shell and just go ahead and query interface into the iUnknown pointer need to return here. That's called pp iUnknown item. Let's roll with that. So I'm just going to copy this, or to put that inside this pointer to a pointer, and this also conveniently returns an H result, which is going to be SOK, because the object definitely supports iUnknown, and we're basically done. So that's going to create the object the first time it is used. An alternative, of course, is to create the object up front when the script host just starts up, and then just return that object every time that it is being asked for. But in this case, it's slightly more, I would say, efficient, because maybe the script is not going to call this shell object at all. So now we can check that. Let's go ahead and put a breakpoint right here and run this thing right now. So the message box is going to appear again. I think I need to remove that because it's a bit annoying, but here goes. Here's the message box. And then we get to get item info. We can look at the call stack and see that it is coming from VBScript. So VBScript.dll, our implementation for the VBScript engine, calls into our host in this function get item info. We can see that the name is indeed shell. We can see the client is using shell with just a capital S, but it doesn't matter. The comparison succeeds regardless, because we're doing a case insensitive comparison. So we have a null pointer here at this point. We're going to create it. Hopefully this should work, and it does. And if it doesn't, it'll just return null, which is going to fail the request anyway. But now we can continue, and we can see that we get to leave script, and in fact we can see system 32 is being launched. So that's a nice thing to do. We can extend this idea so that we can have any number of named objects that mean something. And so we can, of course, call other functions here that exist in this shell object. And maybe the question is, how do I know what I can actually call? Let's just remove this message box because it's kind of annoying. What are the other functions I can call here? And so to get to that information, which is not really related to the scripting thing here, but I think it's a good thing to know. I don't recall if I've shown that in some earlier video. And so what we need to do is to find a way to locate the type library that this shell.application thing is actually implemented with. So the type library is like a metadata indicating what that particular COM component with all its classes and interfaces actually support. So how do we get to that? How do we get to that type library? How can we find it if it exists? And so first we can start with the registry. I'm going to launch the registry viewer here, and I'm going to look for shell.application, which is the thing we're actually creating here. And so remember that programmatic IDs are directly under HKey classes root. So here's shell.application, and this is where we see the class ID. We've seen that in the previous video, but I think we've seen that in the previous video, even though it might have been in relation to the VBScript engine itself. So that's the programmatic ID, and that's the actual class ID. And we can go to that. Maybe we'll find some information about the type library, and we will actually. But I want to show you maybe another way. You know what? Let's just use both ways. So first, let's grab the class ID. I'm going to just copy this class ID, and we know that we need to search for it under the CLS ID key here. So let's just go ahead and open that up and do a find and paste this thing and find it. So here goes. You can see that here we have the type library. There's a type library here. Of course, we have the DLL itself, which happens to be shell32.dll. This is where this object, or this class to be more precise, is implemented. We can see the prog ID, which is not very surprising. And there's the type library itself. So type library also has a GUID, and type libraries can also be registered in the world of COM under another key called type lib. So technically we could go and follow that link, so to speak. So we can go back to type lib here and open that up and use find again, this time paste something different, the type library ID. And we can see here, once we open that up, there's a version here, which is typically 1, and then under 0, there's Win32, and this is where we see the actual type library. So type library is actually in shell32 itself, which might seem a bit weird, but it's not that weird, because in many cases the type library is bundled within the DLL or within the executable or whatever file is used to implement that COM component. So we have that type library here somewhere, which is good enough, which means that we can take this shell32.dll in the 32 or 64-bit variant and get to the actual information. But how do we actually see that? So for that, we want to use another tool that is called Overview. And so to get to that, we need to open up the developer command window from Visual Studio. So here's the one. I'm just typing that in the start search. And we get to this window here, and the tool name is Overview. So I'm just going to type it in. It's going to open up. This is just makes it easier to find it because it's in the search path that is provided by the developer command prompt. And here's where we need to locate our actual information. And so there are two ways of going about it. Since we know what the type library is, we can go ahead and use this button to browse any type library. So I can go to Windows, System32, and should be shell32.dll here. And this is the one that's supposed to host the actual type library. And if we try to open that up, it might not work as expected, because we might need to launch this thing as administrators. So let me relaunch the command window here as an administrator. Maybe we'll have better luck, so to speak, by browsing to something like shell 32. So here it goes. Let's try this now. And you can see the type library viewer pops up, and here's where you can see various classes like the shell class. That's in fact the class we were actually using. We can verify by looking at the class ID. I'll leave that to you as an exercise. It's implementing this interface called iShellDispatch6, and you can see it has lots and lots of methods here. One of them is actually this explore method that we've seen, and we've used that. That's the explore method. You can see there are many other methods here that are available. In fact, some of them are actually properties. For example, there's the option here to do something like run an executable or run something. Here's a shell execute method that's supposed to run some kind of file. Could be an executable, could be something like a doc file that would cause Word to open up, something like that. So it's very similar to the shell execute API in Windows, if you're familiar with that, but that's just a method on this object, which means that we can do other things. Instead of using explore here, we can do something like a shell execute and run something, say paint. Let's just try to run paint. So if I go ahead and run this time I'm going to run without the debugger just to save some time. Well, actually I ran that with the debugger. Anyway, we'll see that paint pops up, and it did here on my other screen. So this is a way to see what is actually available. That is one way to see that. The other way is to locate the actual class in the list of classes in the original view, but we should get to the same exact location. Of course, we'll see the same type library. Let me show you how you can get to that location. So going back to the registry, we looked at the class ID here, and the class ID, we found that particular one. That's the, let me just go back to the beginning here. We have shell.application. That's the class ID. We grab that class ID and then look that up under CLS ID. And when we look that up, one of the things that we see, and this is not obvious, is that the name we see here on the right, in this case it's called Shell Automation Service. This is just a friendly name. It has no meaning in from practical purposes, but that's the name that's going to be used by the Olecom object viewer to show stuff here in its all objects node. So if I open all objects, which really should be called all classes, but that's what we have, I need to look for something called Shell Automation Service. So I'm going to look for that. So here's Shell Automation Service. That's the one. And if I open that up, you can see it supports multiple interfaces like iShellDispatch5 and things that we've seen there in the type library viewer. And of course, it supports iDispatch. This is necessary for that to be an automation object, something that you can invoke from a script. So if you right click here, we can go to view type information. That will open the same view as we've seen previously to show everything that is in that particular type library, which has multiple classes, not just this particular one. And again, we get to the same list of methods and so on, which we can then use. And so you can see there's lots of interesting stuff here you might want to experiment with. And this is why one of the reasons that scripts are sometimes considered dangerous, because they can do stuff like launch processes and do many other things because of the existence of COM components that provide this functionality indirectly. And the script can invoke those COM components, like in this particular case. And so we can use shell execute here, just like we've seen. We can use, of course, something like explore, as we've seen previously, like open something like some kind of directory. That's all good and well, and this works. But as far as this idea of exposing a named object, we can go even one step further if we so desire. So maybe we want to say this shell execute and explore, let's just make them like global methods or global functions, if you will, that we can just launch directly. So just call directly in the script, just like if I would call something which is inherent in VBScript, like message box. So message box here, obviously I don't have to do anything for that to work, because this is inherent in the VBScript engine. Can I add these kinds of things myself, like say shell execute and explore directly without actually having any particular prefix, just like that? it's definitely simpler. So if I try to do that right now, it's probably not going to work out. So we can see we get into some kind of script error, and the error just says, you know what, I have no idea what shell execute is. I really don't know what to do with that kind of thing. And so what we can do, and of course we need to be slightly careful here, because we have, in this case, we have these names, and these names might be exposed to the outside world. This explore and shell execute, and if in fact these are any one of them might be a VBScript keyword that would cause a collision, which will fail the script regardless. But assuming that these things are not inherent into VBScript, we can expose them globally by using another flag when calling end name item. So what we can do here, we can add a flag called script item and global members. What that does is essentially saying that everything that is part of this shell object, whatever members it has, they should now be exposed directly to the global namespace, so that the name shell itself is no longer needed. And we can use just the actual members, and that is it. So let's try this. So we have two things that's supposed to happen here. We're supposed to see a shell execute of paint launching again, and then we supposed to see windows opening up in Explorer, and then a message box. Let me just press F5 to see if that actually works and there's no errors. So obviously you can see we get to this shell object because it is used behind the scenes because of its visibility there. And now you can see that indeed it works as expected. We get the message box, we get all these things working for us. So we've extended the scripting possibilities here just by exposing these names directly as just like normal functions, or looks like perhaps keywords as part of the VBScript engine, just like message box. But obviously they're not, they're just child members of this object which has this name, and this is where this thing is being properly registered. And so what we see here is that we have this nice ability to extend the scripting engine in interesting ways. And by the way, it doesn't really have to be that particular kind of class I'm using here, this shell application that is provided by Windows out of the box. We can create something completely different for ourselves. We can create any kind of COM class that we want. For example, we can create a COM class representing a turtle in the classic logo language from the 80s. And that turtle is able to draw stuff by moving forward and rotating and things like that. So if this is something that you're interested to see, in order to see if you can script that thing and actually see things graphically, not just in a text-based fashion, just hit me up in the comments. I'll be happy to create such a video if that is of interest. But feel free to play around with this idea of extending a scripting host in various ways. Of course, these things are documented and not very well documented, I would say, but still documented enough at least to get you going, as you can see in this example. So this is it for this video. Happy scripting.